All right. Hi, everybody. Welcome. Thank you for your patience. Pull out your calculator from yesterday, your calculator. I'm going to revisit something we did last class because I forgot to show you one thing. Hopefully you still have L1s, 2s, and 3s. Actually, I'm going to wait, and I'll do that in a minute. I'm going to tell you the other announcements first. Everyone will be here for the calculator stuff. The test is in a week and a half, and that's going to cover lessons 1 through 9. I'd like to know how confident you feel about the upcoming test. Those of you that are only feeling so-so, what I would suggest is start figuring out now things you can do to help yourself feel more confident. A couple things that I saw from the discussion boards. For the most part, almost all of you thought Maha's study technique was very helpful. There were a number of people who thought it was very time consuming though, and I totally get that. So what I'm hoping is that maybe you'll find some middle ground, pick some techniques of what she did that you thought were helpful, but that were also less time consuming than doing the whole things that she did. Our classmate had shared her summaries of the lessons. That might be a good thing for you to do on your own as well. Again, that is a little bit time consuming, but think about some common ground. Has anyone kind of developed an in-between that's not all of Maha's technique, but picking and choosing the 6 ones that work best for you and adapting those for your own? Did I hear a yes?
Yes.
Okay. Oh, would you mind sharing what you did?
Yeah, I created like the colorful notes by lesson, but what I find the most helpful is on the front of my notebook, I have like just a quick nitty-gritty formulas that seem to come up and like a cliff notes almost of the notes. So that's where I know to flip first if I can't figure something out. But yeah, the coloring in the notes and making that so that's my shortcut, is that basically what you asked.
Okay,
Yeah.
cool. Thank you for sharing that. So hopefully you will find something that will help you. And I know a lot of you thought that teaching technique that she used really helped you. So maybe even finding a way to do that in a shorter way. And because almost everybody thought that was also helpful for helping you a little better understanding for a topic. And I certainly found that too when I was a student and I was trying to work through a really difficult problem or a really difficult concept. I personally found talking to myself was extremely helpful, and I would pace around the room talking to myself. The research shows that talking out loud, be it to a fake person, to a real person, to yourself, actually helps you learn because your brain processes things differently when it's hearing versus when it's reading. That process of articulating the concept, in order for that to happen, your brain has to sort through things in a way that allows you to articulate them. So when someone says, well, I know how to do it, but I can't explain it to you, that means they truly don't have a solid understanding of how to do it. You have a surface level understanding of how to do it. If you can't articulate it, you don't know it well enough to do it well on a test. That's why that teaching technique is good, and why tutoring the same class that you're learning is actually really helpful to you. Okay, which is why I put you in groups, because I'm hoping that's when you'll be talking to each other. If you can, I would say unmute yourselves, and then you can mutter to each other and talk to each other and in a more conversational manner, having to go, wait a minute, oh shoot, I'm muted still, and unmuting yourself. When you're in those small groups, stay unmuted so you can have that more natural conversation. I think you'll find that to be more helpful. And I see on the chat, people are saying nobody talks in the breakout rooms, and that's sad. And I thought that was really unfortunate. I really wish you folks would talk to each other in the breakout rooms. The whole point of those breakout rooms is to help each other, talking to each other, working through problems together, be it in the chat or in person. As long as there's some kind of conversation happening, I'm good. because I know when I come in, most of the time you're all muted. All I ask is that you communicate with each other in some fashion in these breakout rooms, okay? Let me show you something with this calculator. Pull out your calculator, and hopefully you still have everything in L1, L2, and L3 from that last problem we did last class. We're going to go to Stat Edit. Here's my data from Lesson 7, Example 3. I just wanted to show you making those box plots. Remember, we need the min, Q1, the median, Q3, and the max, 5-number summary. You can find these manually without too much trouble for these lists. But I want to show you how to get it using the calculator. Go to Stat, Calc, so one variable stat, press Enter, and this will give us the 5-number summary for each. Now you see this one says L2. If we want L1 or L3, we have to hit second 1. That gives us L1, second 2 gives you L2, second 3 gives you L3. Okay, and then Enter, Enter, and calculate. Those of you with a calculator that doesn't show this screen, give me a thumbs up if you have a calculator that looks like this. Okay, I see there's a couple people. So what you do then, if your calculator doesn't have that option, that menu, we have a slightly older calculators, then you see here, it doesn't tell you the L1, L2, it defaults to L1. So if I press Enter from here, it gives me the information for L1. I'm going to go back and do that again. From here, if I want L2 or L3, I have to immediately, after this shows up on the screen, get L2 or L3 on there. So I'm going to press second 2, and so now it's going to pull the data from L2. So if Enter, there's your data for L2. So that's how to do it these old ways. I'm going to go back to my emulator. So you should have all of this if you're doing L1. Now remember, this arrow here means there's more information below, but you see here's the min. This is where 5-number summary is starting. Q1 is 26, and this should match what we found on our paper. Okay, and the X just is because sometimes we're going to be doing this with 2 variables. One set will have X and one set will have Y. Let me show you this other thing. If you hit the Zoom 9 for Zoom Stat, and here's our 3 box plots. This is really cool. Press the trace button up here on the top next to the zoom button, and you see how up at the top it says plot 1 L1, but look at what it says on the bottom. It gives you the median. If you arrow over to the right, it gives you Q3. Arrow over to the right, it gives you the max. If we arrow down, that puts us on the middle set of data, what's on L2, max, arrow to the left, Q3, median, Q1, min. So we can get that information from our graph. Finally, one last thing I want to mention to you is about the placebo study. Folks had a lot of really interesting thoughts. I just want to make sure you all understand that the information they gathered on all those studies, including the price, were the results of an experiment. People weren't actually paying $500 for the placebo. And they've actually done a similar experiment with wine. They have found that if they do a taste test of wine and they tell people, here's a really expensive bottle, here's a $50 bottle, here's a $10 bottle, which of these tastes better? Even if it's the same bottle of wine, overwhelmingly people will say the expensive bottle of wine tastes better, because in our minds we have this idea that it's more expensive, it'll taste better. So the same is true with medicine. Also, another interesting way the mind works. Is anyone here familiar with what's called phantom limb syndrome? So here's a really interesting thing that they've done with people who lost limbs, feet, legs, and I'm sure it would probably work with fingers as well, is this thing called mirror therapy. When people lose a limb, they get pain as if that thing is still there. Okay? And I have it too after my surgery. What my doctor told me is when it hurts to touch it. And then when you go to touch the thing and it's not there, it helps your brain understand that the thing is gone, because the brain doesn't realize that thing is gone. But one thing they found that's been super helpful is mirror therapy. Patient looks at the mirror, and you see here she's lost her foot, but she looks in the mirror, her brain sees the foot is still there. By virtue of looking at the mirror and the brain seeing, oh, the limb is there, helps the pain go away, because the brain is in shock that all of a sudden this thing is gone, and so the nerves are in pain. But this mirror therapy has been shown for most people to alleviate the pain. That's just another example of the brain being very powerful and to suggestion. Also, just a fun fact, the phantom limb syndrome is there is no leg or arm or limb, and the brain thinks it's still there and thinks it's still all blown up and in a lot of pain. There's the opposite of that, where people have a limb that they don't think is theirs. I have my arm and I think this is someone else's arm, and I can't figure out why people are messing with me and putting someone else's arm on me. It's a real thing. thing. I took this great class at UC Berkeley called Brain and Mind and Behavior. It was phenomenal. The funnest class by far that I've ever had. That's your interesting tidbits for the day. Okay, so let's move on to lesson 8, scatter plots and correlation. For your homework, you were asked to do that worksheet and look at the correlations. Just off the bat, I'm going to launch a poll. How are you feeling about this topic? Hopefully today will help everybody have a little better of an understanding. I'm just going to go over the answers. iPad having issues today, so we're going to do this old school. The correlations are something that we're going to be talking about for this class and next class. In lesson 9, we'll learn where R comes from. The whole idea is from the R value is we look at what's the general direction of the data. Is it trending up or is it trending down or is there no trend? And then the strength, how well the dots fit the shape of a line. We can do all kinds of shapes. For this class, we're doing lines because what we're doing in lesson 9 is we're looking at the equations of the lines. And that's where R comes into play. It is going to be a y equals mx plus b, but not to the level that you learned perhaps in algebra. So look at 2 things, direction and strength, how well it fits the shape of a line. We here are our general guidelines, finer than I'll be asking you to do in class. We generally say none, low to moderate, very strong, pretty strong, and near perfect. So when you're trying to guess the pattern, we're doing an educated guess. I'm not looking for the exact same values. We may guess close to the same values, but I don't expect you for this first one, for instance, to get a 0.95. I suggest you look at these in 2 different ways. First of all, the direction. Is it pointed up or pointed down? That tells you if it's positive or negative. And then look and see how well do they make a line. And you see this first one makes a line pretty darn well. I guessed a 0.95 because remember a 1 means it's perfect. You could take a ruler and line them completely. So these are just what I got just with my general ballparking. Okay, you should at least be able to guess the plus or minus. Is it terrible, decent, or really good is all I'm asking. Okay, 0.6 being it's a decent trend of a downward line. 0.95 that's really good. Going to the 0 here, that's terrible. You can't even tell if it's up or down, and that's why I chose 0. Then we have some matchings, and this was just a check to see how close were you. When we're doing this matching thing, here's another tip. First of all, use the plus and minus. For instance, if we look at C, that's a -1. That narrows it down already. If it's going up, you know the answer is not negative. If it's a 0.9, you know it's a really strong, it's better look really close to a line. Use the really obvious ones to narrow down the field, and then you can go to like these 0.5 versus 0.7. That's a little bit harder to gauge. But these nearly perfect ones, you could gauge pretty well. The 0 you could gauge pretty well. And then on these next ones, I was just asking you to come up with some pattern. And again, just like the earlier ones, there's no real one answer. As long as your friend can look at it and go, oh yeah, that's trending upwards or downwards, we're going to call it good. So let's get a little bit of practice in. I'm going to show you some graphs. I'm going to ask you to put in the chat what you think the correlation is. This one, I'd ask you to do a couple of these as part of the pre-class assignment. But the annoying thing with this website is if you don't guess the exact right number, you're marked wrong, which I think is ludicrous. It should be in a plus or minus ballpark. Guess the correlation. First thing you should think about, is it trending up, down, or is there no trend at all? That is to say, we read it left to right. So from left to right, if it's going upwards, then it's positive. If it's going downwards, then it's negative. What do you see? What's your guess? And if it's positive, just put the number. See, 6s, 0.6, 0.8, 0.7, 0.5. I think there's a little bit of a better trend there than a 0.5, 0.6, but that's just my opinion. So since most people said between 0.6 and 0.8, we're going to put a 0.7 in there. Oh, hey, it's better than I was even guessing. Okay, let's try another one. So what's your guess here? And we saw the last one was 0.8. Is this one better or worse? Okay, I'm seeing a lot of the same numbers because it does look almost exactly like the last one, doesn't it? Except it's going downwards. I think everyone agrees it's a negative. 0.8, oh, now we're much heavier in the 0.6 range. I'm gonna put negative 0.6. By the way, those of you going in the nursing field are gonna be required to put this 0 here. It's called a leading 0, and it literally saves lives. It's required in the medical industry now because there was a problem with nurses administering drugs, not noticing the 0 point and giving people 6 millimeters of a drug instead of 0.6 millimeters. People were literally dying. Okay, so let's let's try negative 0.6. Negative 0.8 again. Okay. Even though it's got these out here, there is definitely a very clear downward trend. It's a moderately strong trend. Okay, let's try another one. Negative or positive, how good does it fit the shape of a line? Okay, we see some negative 0.5s, 0.6s, negative 0.7s. I see most people are between a negative 0.5 and a negative 0.7. I'm going to do negative 0.6. Oh, hey, look at you folks. You were right on this. Let's do one more because this is fun. Okay, what about this one? Start out with, is it going upwards or downwards? That would tell you plus or minus. And then how good does it fit the shape of a line? I see lots of zeros. Pretty much everything is 0.5 or below. What I'm putting in here is just based on what I see you folks saying. I'm answering for you. Most of people agree it's somewhere between 0.3, 0.4. Let's try. Oh, sorry, you folks did say positive. That's on me. So good job on the positive 0.3. I guess it's positive. I can kind of see that. So you folks were more right than I was. All right, good job. There's no one right answer. There's a lot of wiggle room in these, which is why we prefer to use the calculator. But on the test, I will absolutely ask you to give a guess, but it'll be multiple choice. So you'll just be able to choose from the ones I give you. Remember, you can help narrow it down. If it's obviously positive or negative, throw out half the option. What we use correlations for is to see if there's connection between two pieces of data. For instance, there is research to show ice cream sales and crimes are related to each other. They correlate to each other fairly strongly, in fact. Does that mean that crime is due to ice cream sales? I see a couple people say no. Okay, what other things could affect the crime rate increasing and ice cream sales increasing? Someone said in the chat, it could have to do with the season, right? And the heat. Yeah, exactly. So there's these other things having to relate with it. Ice cream sales go up when it's hot. Crime goes up when it's hot. So it's hot, they both go up. So that's a common thing to do, is to look at two things that are related and say that one causes the other, but that's not necessarily true. I'm going to show you this video real quick.
I got a joke about silly correlations. There was this American who was afraid of heart attack, and he found out that the Japanese ate very little fat and almost didn't drink wine, but they had much less heart attacks than the American. But on the other hand, he also found out that the French eat as much fat as the Americans and they drink much more wine, but they also have less heart attacks. So he concluded that what kills you is speaking English.
Okay, so that's one of my favorite correlations. They both correlated to speaking English, but that doesn't mean that's what caused the heart attacks. So there's a name for that. It's called spurious. Those are called a spurious correlation. It's one of my favorite words. Spurious correlations are two things that are both strongly connected in terms of how they're increasing or decreasing, but they have nothing to do with each other. Now, I'm going to have you look at this website and scroll through it and find your favorite spurious relationship. They found each set of data differently, and they just put them side by side.
I said it before, I'll say it now. If nobody's brave enough to call it out, then I will. Nicolas Cage is drowning people, and it's a problem, and somebody needs to stop him, okay?
That's true. It's absolutely
That's
correct.
just facts. Everyone knows it's happening. Just because we haven't caught him yet doesn't mean it's not happening.
I personally dealt with it myself. I've seen it with my own eyes.
See, my theory is that he's just yelling so much, and they just jump in to get away from it. Okay, so what was your favorites? Nicolas Cage and people drowning in a pool is clearly a favorite.
The spelling bee and the venomous spiders.
That is awesome. And look at that correlation. Did you notice, folks, that it has the correlation on the bottom there, about below the title? What about group 3?
The per capita cheese consumption correlates with the number of people who died by becoming tangled in their bedsheet.
Ah, yes, the tangled in your bed sheet. Ah, here it is. Oh, no, wait, that's mozzarella cheese in civil engineering. Lots of doctorates. Getting a doctorate is correlated to a lot of really scary stuff. And it's increasing.
We kind of like the marriage rate in Kentucky and the people falling off of votes.
Look how strong that correlation is. And so notice this R value is a percentage. So they're writing it as both a percent and a decimal. And does everyone see that the red graph is 1? So the left has a different scale than the one on the right. Meg pointed out that I have a doctorate. I'm part of the problem. To be fair, my doctorate is not listed on here. I am not part of this problem. My doctorate is not in math. I am not. Did you have a favorite?
Marijuana arrests with bee pollination.
Age of Miss America and murders by steam, hot vapors, and hot objects. What? Okay. Honeybee colonies and marriage rates in Vermont. Honeybees and divorce rates in South Carolina. Here's another doctorate. And death caused by anticoagulants. Accidents involving a fishing boat and visitors to Tokyo Disneyland. What we're doing next in lesson 9, we're taking those scatter plots, and when the two things are actually related, we're not going to be doing this for cheese consumption and Nicolas Cage. We're doing things that are actually related to each other, not spurious. We want to use those scatter plots to make a prediction. But in order to make a prediction, we need to have a model of some sort. And so that's where these equations of lines are going to come in. I'm just going to give you a quick preview of what we're going to do. This is just the scatter plots from lesson 8. We have this existing data. For number 1, we have this data that's already existing. What we want to do is we want to make a line that fits that data as best as it can so that we can use it to make predictions. And they don't actually have to be related to each other. We could do, I don't mean soda, I mean ice cream. We could look at spurious correlations. We can look at the relationship of ice cream and crime. And what we want to do is we want to take this data and find the line that fits this data the best. Because remember that R value is a way to indicate how good the data fits a line. I think most of you could probably do a line on this one. So grab your worksheets and try to make a line on that. That's a pretty good relationship there, yeah? You can see it's not 100%, not exactly lined up on a line, but it's pretty good. So now look at number 2, and on your worksheet, and this is when some kind of straight edges help you, because it helps kind of see a little bit, or even just take a pencil and see like where would you put that line that fits the data the best, that is most representative of all. And this is another thing where when you're ballparking it and when we're doing this by hand, we're not all going to get the same answers. But if I did a line like this, would you all agree that that's not a good line? It's a line, it goes through 2 data points, but it's not a line that represents all that data. So you want a line that represents the data the most. If I do it down here, again, now I have it in the right direction, but you see all the data is way up there. So it's going in the right direction, but not representing the information I have very well. So we don't want to do that one. But what if I do something like, okay, do you see how that is going in the same direction as the data, follows the pattern, all the data is pretty surrounded by that line? Would you agree that that's the better of the 3 that I've drawn? I'm not really going to be asking you to do this too much. We're going to be using our calculator, but it's a good skill. And this is something that for these next 4, take a moment and see if you can find that line that fits the data the best. Doing number 3, positive, but not super positive. I'm going to go something that falls right in the middle. Did you get something around that? Again, we're not all going to get the same exact thing. 4 was one that R value was 0, or close to it. This one doesn't really have a clear pattern. So this line's going to be more like that. Your answer isn't necessarily going to look exactly like mine. So number 5, this is going downwards. So I'm going to go with something like that. But do you notice in all of these, the line goes pretty much through the center of the data? Now this one, the R was like 9, something like this. So that's the whole point of what we're doing in lesson 9. But like I said, we're going to be using our calculator. I would like to double check that our calculator is set up correctly. Pull out your calculator. We're going to go back to stat, okay, and then calc. Remember, calc means calculate, so we're going to arrow over to that. And you see number 4 here? This says lin reg ax plus b. That means linear regression, ax plus b, as in what you would have known from algebra, mx plus b, the equation of a line. Linear means that we're doing linear modeling. If you scroll down, there's a whole bunch of different options here. Here you see quadratic modeling. This is if we're going to use a quadratic equation, a cubic equation, quartic, so x squared, x third power, x to the fourth power. Okay, we're going to stick with lines. And it's called a regression line for technical reasons, really a fancy way to indicate how we're determining the line. What's nice is on this menu, you can just press the number 4. You don't have to arrow down. down. Okay, we're going to use L1 and L2. Scroll down, leave frequency list alone as with, so from here, this is if we're going to store it. So click vars and then scroll over to the right to Y vars. If you don't have this easily, then don't worry about this. Press 1 and then press 1 again for Y1. Okay, and then scroll down and click enter. Those of you who have this other calculator, I'll show you how to do this. We're going to do the similar thing. Press stat, scroll over to calc and scroll down again, press 4. And you see how, like before, this is a different setup. So we have to tell it which columns to take the data from. It defaults to L1 and L2. For our purposes, just leave it like this. We're only ever going to use L1 and L2. Press enter and you see on this calculator, I got that. We want to get all these R's. If you did not get R, R2, which is R squared, then we need to turn something on. Okay, you see in this one, I haven't turned it on yet. What we need to do is go to second 0. You see how it says catalog? And then we're going to scroll down to D, and we want to look for diagnostics. What we want is diagnostics on. So you see how that little arrow is in front of diagnostic on? Press enter, and then we're gonna press enter, because here this puts it on the screen, but now we need to actually have the calculator perform the operation. So we press enter one more time, and it says done. Now, go back to stat, scroll over to calc, press number 4 for linear regression line. Again, we want L1, L2. The order of this is important. The X list needs to be L1, the Y list is L2. Store the equation, we can try that again. Bars, scroll over to Y, 1, 1, press enter, and now you should have R. Where is it? This is from example 3 on lesson 7, the non-players and the beginners. There's a really strong correlation between those two. And we can graph that. Our graphs are still set for the box plot. If you go to second, Y equals, you see here, we all have these box plots. Press enter. To get in here, we're going to change the type. We want to change it to a scatter plot. So I want L1 for X, L2 for Y, and then I want to go turn off plot 2. So I'm arrowing up. I want to turn off these other ones. Arrow over, enter, turn that off. Repeat for plot 3. Arrow up, highlight plot 3, press enter, turn it off. And the only reason we want to turn those off is because it's going to mess with the window. It'll just be difficult to see. So now I'm going to graph it. So again, we want to go to zoom, stat. So press number 9, and there's the data from L1 and L2. Basically, we're taking L1 and L2 and we're plotting as if they are a coordinate pair, like we were going to graph them as dots. So here's the equation of the line. The A goes with the A, the B goes with the B. So the equation is Y equals 1x plus 10.65. And my R value is 0.97. The only things you're going to actually have to know how to do is putting the data in L1 and L2, which you're all fine with now, and getting that screen I was just showing. And that's the extent of it. Okay, the rest of it was just for fun. Okay, have a good weekend, everybody.